Welcome back. This is lecture 2 of 210, and today we're going to get into web servers. So if you haven't bookmarked the course webpage yet, please bookmark it because that will be the main source of information beyond Piazza, which I'm going to send out the link to soon. So today what you're going to be able to do by the end of lecture is this. You'll be able to tell your friend what happens in detail when they type in a URL in their web browser and hit enter. So that's kind of the story of today. We're going to do a little review of last time. So every lecture is kind of go like this. We're going to start reviewing last time and then pick up from the running example. So last time, remember that we saw how a static web page is just HTML. It's just a file with some HTML and CSS code in it. So we just put the HTML and CSS all in one place. And this time what we're going to do is we're going to cover what is a web server, what is this HTTP thing you've been reading about in the readings, and then finally, we're going to end the story with what happens when you type in a URL and hit enter. So some of you were not here in last class, but that's okay because we didn't actually cover too much. So I'll tell you what we covered. I'll just recap it really fast. What we did is we built up a really simple static web page in HTML and CSS. So this is this course web page. So these are the readings from last time, so you'll have to read over these when you study for the exam. And I usually put up the code from lecture after the lecture. If there's some code you need before, like some skeleton code to set up, I'll put it up beforehand if you want to follow along with examples, but it's completely optional. You don't need to follow along. So I remember I have this lecture1.txt file. I named it .text because then you can actually just open it in your web browser, just a regular text file. But if you want it to display as a web page, if you want to display as a web page, you need to rename it lecture1.html because then the browser opens. So this actually just viewing as the plain text. So this is the code we built up last time, so you can study this on your own. And then we had this truck picture that we downloaded from Reddit. So we had this truck picture we embedded within our homepage. So I just took this code, I cleaned up a little bit and put it online. And today we're going to talk about the web servers. You don't actually need this download right now for this class, but it's a good idea to download it offline because the internet's slow in here and we don't want like 80 people downloading a 300 megabyte file all at the same time. So just do this on your own time if you want to follow along. So recall that what we did last time was we just wrote an HTML file here. So we had this truck picture we downloaded from online. We have this lecture1.html file. We just edited this with, open with Sublime Text here. Well, I don't have it open, but if you open it up with your web browser, remember this is the page we displayed, right? There's my heading, there's some subheadings, there's a picture, there's some paragraph text, and we colored one of these things red. So this is good and all. You can imagine making all your favorite web pages like this, writing it on your computer, and also just displaying on your computer. I mean, this is perfectly fine. These are just files you put on your computer. But the problem, of course, is that no one else can see these, right? Like only you can see these because they're on your computer. Unless someone else like goes on your computer, they can't see these files. So ideally, you want a way for people all over the internet to look at these files. So in order to do so, we need to set up what's called a web server to serve these files to people. So what I've done is I made an exact copy of these files to my own web server on my personal website. So if you actually visit on the URL, remember this is on the computer. If you visit pgbovine.net/lecture1.html, just the exact link, you press enter, you see the exact same thing. This is the exact same page, right, with the truck picture. So I just uploaded the file and the truck picture. And now if you notice, if you're on your laptop or your phone, anyone can see this. It's because it's not on my computer, it's somewhere on some server, which I'll talk about. So let's talk about what a web server is very briefly. So we'll go to the diagrams. My notes are on my phone, so I don't want to print out too many pages. Okay, so what is a web server? So let's go back to the drawings here. So we're going to cover this first part first. So what is a web server? So all the web server is just a computer connected to the internet. Like that's all you have to think about. It's, a web server is just, the terminology is kind of misleading, but web server is just computer connected to internet somehow. So this is a very general definition. So anybody's computer can technically be a web server. So people usually think of web servers as, these kind of really advanced machines living somewhere special. But really, anybody's computer, their laptop, their desktop computer, as long as you're connected to the internet, you can be a web server. Because all a web server does is connect to the internet and serve files to people who are requesting them from anywhere on the internet. So of course, if your computer is not connected to the internet, you can't really have a web server that does anything. You can still start a web server, but only you can see it because it's just on your computer. So the term is kind of strange because there's this term of web server, which is the computer, and then there's also some people call a web server or web server software, and that's actually the software that runs on this computer that's a server. So you might hear the term web server used for both the hardware part, which is the computer itself, and the piece of software that actually serves the web pages. So people use these usually interchangeably. So conceptually, remember from the first lecture where we had this image of a web browser, right? This is your laptop here or your desktop computer, and you have a web browser, and you say www.reddit.com or whatever your favorite website is. You hit enter, and this makes a request to some server somewhere. And this is the reddit.com server, right? This is reddit.com. And this makes a request to the server. The server does something behind the scenes, and then it gives you back a piece of HTML or some other data. And then the browser shows the HTML to the screen as a web page. So that was the basics from last time. So you have a web browser somewhere on your computer. You make a request to the server does something, gives you back some HTML or some other data. It might also give you a JPEG or a picture, right? So Reddit has a lot of HTML web pages, and it has a lot of JPEGs and other sorts of GIFs and PNGs and other sorts of image files that it serves back to you. And the job of your web browser is to take all these files that it gives back to you and piece it together into a nice looking web page. So all these other laptops of all your friends and other people around the world can also do the same thing. They can connect to the web server, and it sends it back, and so forth, right? So a server can handle requests from a bunch of different people around the world, usually at the same time. But the basic architecture is you're going to talk to the server, you're going to make a request, and then it's going to send something back to you. Does it make sense so far? Okay, so let me clean up this picture a bit. So where is this web server? So we'll talk about this right now. So we have the browser, we have the server. So where is this web server? So if you notice like the CS department web pages, so if you have a CS account, you should be able to set up a web page within the CS department, like cs.rochester.edu/user, whatever. You might also be able to set up a web page just under Rochester EDU, depending on your student account. So those web servers are managed by the school. So I don't actually know where they live. Maybe they're in like on campus somewhere in the basement somewhere. Maybe the school actually contracts out to some other vendor off campus to store them. But those are computers somewhere. You can also run a web server from your own dorm room if you have the right, if you go through the right channels with the IT people. You have a computer in your dorm room. You plug it into the wired internet, and then you go ask the IT people to set something up to give you an IP address or a domain name or so forth. And you can actually run a web server from your dorm room. Or what you can do is you can buy or rent space from the internet. That's what usually a lot of people do. So there's a lot of low cost and also some free web hosting providers that give you server space. So for the purpose of this class, we don't really care what the web server is. We just care that it's there and it's on the internet somewhere. I'll give you an example. So the thing I use for my own website, so this pgbovine.net, my website is hosted on this service called WebFaction, and this is one I've used for many years. It's about $10 a month, which is about usual for these sorts of things. There are some that are a little cheaper. There are some free services as well that lets you host for a trial and everything. But basically what these are you pay them whatever a month, and it gives you some space on their server. So it gives you 1 gigabyte, or actually this gives you a lot. Let's look at the features. $850 a month. It gives you 100 gigabytes of disk space, which means that you can store 100 gigabytes of files and other materials on there to serve on your website, and then it gives you a bunch of other stuff. So this essentially gives you a machine or a part of a machine somewhere on the internet that's connected to some fast internet connection. So what do these look like? So these things are usually stored in what's called data centers. If you look up data center on Google, you'll see these enormous kind of rooms, usually in in cooled buildings with just a ton of computers in them. Like these things are all like, each one of these things is a computer, and they all have these really fast network connections that connect to each other, and they connect all over the world. So when people are saying like, what is the cloud or cloud computing, this is really what it is. It's just a bunch of computers sitting in a lot of places, and they're just fast computers, and they're just running software that can serve data on the web. So if you look at all these, I mean, all these data centers look really similar. And, you know, big companies like Google have these data centers all around the world in like secret undisclosed locations so they don't get bombed or something. But, you know, you want these all over the world usually because people are visiting your website from all over the world. So if you're running a giant site like Google, you want, you know, my laptop here will connect to the closest Google server. It won't connect to the one in Asia. But if you're in Asia, we'll connect to the one in Asia. So that's the hardware part of the web server. So the basic thing to get about the hardware of the web server is that it's just a computer. Now we're going to talk about the software part. So what operating system runs on web servers? Ideas? What operating system must the web server run? Suggestions, ideas? Yep.
Whatever they feel is the most optimal one for their application.
Good. That's the best answer. It's whatever works. So they don't have to run any particular operating system. So there are servers that are hosted on Windows, servers are hosted on Linux, and servers that are actually hosted on Apple computers. Although those are less common. So most web servers are usually based on Linux. Or there's a bunch of Windows ones as well. So you just need some operating system. It's just a computer, right? It's just some computer with some operating system. So you have an operating system on it, and then you also have a part which is confusingly called a web server also, but I call this the web server software. So just because your computer is connected to the internet doesn't mean you're running a web server piece of software on it, right? So all of your computers now and mine are connected to the internet, but that doesn't mean that I can put files on there and have people go visit a URL and come to me and find a file and fetch it, right? And same thing with your computers. Your computers are not allowing people, right now, let's say you have a computer here, either in your dorm room or even your laptop here. Nobody can go like this and request a file and have you bring it back to them, right, in their web browser. Unless you set something up. Because if you could, that would be kind of weird, because then you'll allow everybody essentially to see all your files all the time, right? So it's not exactly a good thing. So by default, you can't do that. But in order to allow you to do that, what you need is to run a piece of software on your computer. So this is a piece of software, which is confusingly also called a web server. You need a piece of software that actually listens for people trying to connect on in a specific kind of way, processes those requests, and this is the code that runs to do something. You listen to it, and then you reply with some data back to the browser. So have people heard of different kinds of what's called web server software from before? Any ideas?
Apache.
Yep, so somebody yelled out something.
Apache.
Okay, so Apache is one. Yep.
I think Hamachi.
Okay. Other ones?
Nginx.
Okay, Nginx. Yeah, I don't ever know how to pronounce that. Is it Nginx or something? Yeah. Don't know how to pronounce that. Okay. Other ones? Yeah. Mongoose. Yeah. So that's that's one of the newer ones. So basically, there are just pieces of software you run. Some of them you buy, some of them you don't. Some of them are free. So the most common ones are, let's look at the most common. So this is from January. I mean, this is just trivia. You don't actually need to know this. But these are the most common web server pieces of software being used on the internet based on some survey. So Apache is the most common right now. So 39%, I guess, of sites are using it. Almost half the sites on the internet are using it. Microsoft has a web server as well. They sell server software. Most people just think of Microsoft as selling like Windows and Office and stuff, but a lot of their market is actually selling server software, which you never see because it runs in these data centers. So Microsoft server. So Nginx is another one. This is the one that my website is actually hosted on because it's a free server that's actually really fast. And then Google has some. And then there are some of these more niche ones that people mention. So there's like a list somewhere on Wikipedia. I mean, you don't need to memorize these, but there's, the idea is that there's a lot of them. So there's a bunch of these servers written by various people. Some of them are free, some of them aren't. There's like a lot of features in each. But basically, you need some kind of software on your computer that knows how to, so that's Apache or Microsoft or Nginx or some web server software you install on your computer, which is confusingly also called the server, that knows how to take people's requests, do something with them, and then return a response. Yes?
So Google, is it a proprietary web server?
Yeah, Google's is, that's a good question. I think what this means is, where's the comparisons? I think what they mean by the Google one is actually, I don't know if it's Google like allows you to. I think it's just servers run by Google. I think they might have some web server that, because Google serves so much traffic, that might be how they take the survey, but I don't actually know what they do with the survey. Yeah, so Google has this thing called Google App Engine. Some of you might want to use this for your projects because it's free, but it's kind of restrictive in what you can do. So Google has this thing called Google App Engine that hosts a server for you. There's a free trial. That might be what they're talking about, but I think a lot of what they say is Google is the Google servers like Gmail and Google Maps and everything. That's probably their own custom hacked kind of server. Good. Other questions? Cool. So now we know what the web server hardware, which is just a computer, and software. So there's an operating system on here, and that's, as we mentioned, anything. It's Linux, Windows, Mac, some other Unix. It really doesn't matter what it is, as long as it can run the software you want. So there are some companies that run Microsoft Windows and put the Microsoft Server software on it. So there are some companies that run Linux and then put Apache on it, or Nginx or some of these other ones. Okay, so now you have a computer that's connected to the internet, and it has some software that's called a web server that's serving files. Okay, so now what do we do? So now if we configure it correctly, if we get the IT and system people to configure it correctly, what it should allow you to do is this computer should be connected to the internet, and it should actually be listening on a port. So it's called port 80 for HTTP. It doesn't really matter what the number is, but what happens is this computer is connected to the internet, and it's the server software is starting, and it's listening for connection. So it's kind of like putting its ears out and listening to see if anybody's trying to connect with it and say hi to it. And it's always doing that because it's always connected to the internet and it's always on. So that's why it's also important, if you notice these data centers, as a side bit of knowledge, these data centers, a big important part about running these and maintaining them is that you want to make sure these computers are always on and available, and the power is on and it's cooled and it's connected to the internet really fast. Because if your data center goes down, then if you ever try to visit a website it doesn't respond, it's probably because their server is either crashed or the internet connection is disconnected or it's really slow or something. So you really want to have these people maintaining these. That's their whole job, is to make sure everything stays fast and well connected. So assuming that's the case, the server software is listening on port 80. So your computer can actually listen for connections on a ton of ports. So there's a bunch of number of ports, 1, 2, 3, whatever. And some of them are reserved for special kinds of applications. So 80 was the one they picked for what's called HTTP, which is what you've been reading about. So port 80 is called the HTTP port because that's the port that's used for listening to these connections in this language called HTTP, which was in your assigned readings. So what HTTP is that what you do is that you make a request to your web browser and you speak the language of HTTP with the server. So this is a protocol or a language you speak. The server understands HTTP, parses the request, does something to it, and then it returns something to you. Also, the language is also called HTTP. So this diagram looked a little different than the one before because I was saying you make a request and everything. But essentially, you're speaking this language called HTTP. Yes, question? Majority websites use 443. That's a good question. How did you find that out? Okay, so good. So a lot of websites, that's a great question. So 80 is the one for HTTP. There's a lot of websites that actually use port 443. You don't actually, this is just trivia, you don't need to know this, but and this is what's called HTTPS. And that's when you visit websites that have that secure padlock thing on them. So a lot of websites now are actually moving toward HTTPS. So for example, is Google all HTTPS? Yeah, it's all HTTPS. So when you see a website with HTTPS, with a lock thing, we won't get into security in this class, but a lot of websites now are actually moving toward, you're absolutely right, HTTPS, yeah, actually Google is, Twitter is, yep, that's HTTPS also, and you see that like lock sign. But a lot of sites that are ordinary HTTP sites, if you don't have HTTPS on them, and those are 80, but they're just two different ones. HTTPS has a little bit more overhead because you have to encrypt all the traffic. So that's just non-standard right now, but more and more sites are moving toward it because people fear being watched by the NSA, except the NSA can probably watch HTTPS also, so it doesn't actually matter. They were the ones who invented it, probably. So anyway, so yeah, 443 is just called HTTPS, but it's the same idea. It's just a port number. So good question. So HTTP or HTTPS. So the idea is that you connect to a port. So let's say 80 for HTTP. You talk. Now what you have is you have a direct connection to your web server. To this server somewhere, and then you can send it messages, and all messages are just strings of text. So it's just A, B, C, D, E, whatever. It's just like you're texting somebody or sending someone an email or something. You're just sending some messages. The format is called HTTP, which we'll go into a bit. The server understands this language or protocol called HTTP, does something, and talks back to your web browser using this exact same HTTP language. So what is transferred over HTTP? You can transfer plain text, you can transfer HTML files, you can transfer images, you can transfer videos. You can basically transfer anything over HTTP. It's just a text-based format that tells you where to go and such. Okay, so the one part that I've left out so far is how do you find this web server? So let's say this is Reddit server and you have a web browser here. How do I know how to connect to the server over there? Like would I have to tell the browser? Yep. Wow, lots of stereo. Yes, over here, heard stereo somewhere. The domain name, okay, good. And what's the domain name?
It's just a name that is associated with an IP address.
Good, good. So we have terms like domain name and IP address. Good. Right, so you need to know something about domain name, and we won't go into IP addresses in too much detail, but were there other answers, or is it similar sort of thing? Yeah, so basically you need to know, I mean, this kind of gave it away because it said reddit.com, right? But if I said somewhere on Reddit, the reason why you know to connect to this server and not this one somewhere else on the internet, or this one somewhere else on the internet, this is the Facebook server, this is the Twitter server. The reason why you know to connect to reddit.com is your web browser says reddit.com, right? You say reddit.com, that's called the domain name, or some kind of URL. And you know to actually go to that server, the reddit.com one. And if you say twitter.com something, it'll go to Twitter. If you go to Facebook, it'll go to Facebook. So you tell it where to go, right? It doesn't go automatically. So how do we get these domain names? So again, this is something you could, yes?
Well, I was going to say, doesn't it go to DNS?
Right. So we won't cover that in this class. I covered this last year, but it wasn't in your reading. So basically, the domain names map to these things called IP addresses that are your addresses on the internet. But for all intents and purposes for this class, since we're assuming the server's there, we don't care about. I mean, if you take like a networking class or I think mostly networking they cover. It covers a lot of behind the scenes, right? So what happens when you go to reddit.com? A bunch of stuff happens on the internet that's magical for all intents and purposes. A bunch of stuff happens that gets your packets of data all throughout this giant internet to the Reddit server and back. And all of that is magical for this class, and you just hopefully assume it works as long as you're on the internet. There's an entire PhD dissertations that have been written about how this actually seemingly simple process works. Does that make sense? So you type in a URL with a domain name, and then you find that server, and then you do something. Okay, so all right, so we've gotten this far. We have the domain names and the URLs. So let's actually make some requests. So notice here that there's a web browser as a piece of software. This is something like Google Chrome or Safari or Internet Explorer. All a web browser is that something that enables you to connect through HTTP to a server somewhere, and then take the response and make it look all pretty and nice on the on the page itself with graphics and videos and stuff. But really, you don't actually need this piece of software to talk to the server. You can talk with it using some other means. As long as you have software on your laptop that speaks this HTTP language, you should be able to connect to a server. So I'm going to show you how to do that right now. So this is optional. You don't need to actually do this for the class. But so if you open up a terminal, if you have a Mac or a Linux computer, this software should be built into your terminal. If you have Windows, you can get this thing called Cygwin, which is a giant download. You can look this up on your own time, but Cygwin is basically an environment for Windows that gives you a lot of the command line tools that, called Cygwin. It gives you a lot of the command line tools that Windows, that Mac and Linux users have, but this is, again, completely optional. I'm just using Cygwin on this computer because this is a Windows tablet, so I need to use the command line tools, and Cygwin works pretty well. So there's this piece of software called curl, or curl. It's called curl. What this does, it basically allows you to make HTTP requests to a server. So if I do the curl-i option, and I'm going to type in my website /lecture1.html. Notice how this is the exact same URL that I typed in. So I don't have HTTPS. So I gotta go back to HTTP. So notice how this is the exact same URL. Chrome hides the HTTP just to make it look nice. But this is, I'm visiting http://pgbovine.net/lecture1.html. So what this will do when I go to my web server is that it will find pgbovine.net, which is the domain name. It will route it somewhere and go to the server that I'm renting somewhere. I don't even know where it is. It's in Texas or somewhere. It will go there, and then once it finds the server, it will make a request for this path, this file, lecture1.html. I can do the same thing here if I make a request for truck.jpg. That was a truck picture, remember? So I can directly request a truck picture just from the server. So the URL has two parts. It has the domain name, which is in front of the slash, and then everything after the slash is roughly, for all intents and purposes now, roughly the file you want to get, the resources you want to get from the server. So it goes to the internet, finds this, and then requests, say, truck.jpg or lecture1.html. So recall that, so let's do this on the command line right now. So this command, curl-i just shows you to return everything. This actually creates an HTTP GET request. So this, recall what it does is that it actually, so the curl software actually creates an HTTP request and goes and sends it to my server. And then it will take what's given back to me and just print it to the terminal, to the command line screen. So if I do that, and I press enter, I see a bunch of stuff. Okay, so what is this stuff? So I'm going to scroll back up. There's a lot of stuff here. So for those of you who haven't seen the command line, this is just an interface where you can type in commands and press enter, and it runs a command. It basically runs a single program and prints stuff out to the terminal. So so curl is a command line program. I'll run it again. There's some option that I give it the URL. Yes? No. So okay, that's a great question. So currently, my laptop is just a laptop. So the server is actually being hosted here by my hosting provider, which is, this is good. I need to clear this up. This is being hosted by this web faction site, and the server is somewhere, I don't know where it is. It's in Texas or something. So I am using my laptop to connect to somewhere remotely. Through, so my website is on the other end. So actually, let me draw a picture. So let me draw a picture right here. Okay, so this piece of software, this curl piece of software is running on my computer. So let me draw this. Okay, so here's the diagram. There's a server somewhere, and this is the pgbovine.net server. This is living somewhere. I assume it's Texas, because you can actually, when you rent the space, you can actually sometimes choose where you want your stuff to live. A lot of people have it in Texas because it's right in the middle of the US, but you can choose wherever. This is living somewhere in Texas. And this, on the web server, on the server software, there are two files right now. There's a file called lecture1.html, lecture1. There's a file called truck.jpg. So those two files, to answer your question, live on this computer in Texas somewhere. They don't live on my computer. Now, I also have a copy on my computer, but you can ignore that. You can just delete that; it'll still work. These two files live in Texas somewhere, and this computer is running a piece of web server software called Nginx, and this is now listening on port 80. So it's listening for connections on port 80. So this is set up somewhere. So now I have a computer. My computer is here. So this is my laptop right now. This is my current laptop. My laptop is running a piece of software called curl, which is this thing right here. It's running a piece of software. This is actually a terminal. This is a weird picture because I'm like drawing the terminal in the terminal here. But this is my terminal, right? And I'm running, here's the thing, I'm running curl-i, whatever. This is the program on my computer. The curl is on my computer. When I hit enter, what this will do is this will go find the pgbovine.net address, port 80, and it will actually talk an HTTP to it. And then when it does something and responds, it will print out the HTTP response, just the raw response to the screen itself. So does this picture make sense?
Oh.
Yes.
What is port 80?
So
What is the port?
So what is a port? Okay, good. So when your computer is connected to the internet, it can technically accept connections from any other computer on any port, if your software supports it. So 80 is just a number of the port that all web traffic or most web traffic goes through. There's other ports as well. So there's someone mentioned up there, 443 is for secure traffic. Your email travels through another port. I think it's 21 or something. It's basically so that the same computer can accept different kinds of requests. So 80 is just for all web requests, most web requests. You don't have to actually know the number 80, but you just have to know there's something there. Yes?
So it's sort of like tuning into a radio station.
Yes, that's a great analogy. Yes, that is an awesome analogy. I like that. I'm going to use that from now on. That is awesome. That's right. It's like tuning into a radio station. That's a great idea. So there's 443. There's also 21. There's a bunch of them. So yeah, that's exactly right. So that there is a radio tower somewhere, and you can tune into 80, which gets you the HTTP. You can tune into 443 or 21. So the same computer at the same domain name can accept different kinds of traffic. So if you all play, like if you play internet games, the games on the internet are probably using some other port that's not 80. It might be using, I don't know. I mean, you can set up your game server, like a multiplayer game, to accept the connections on whatever it feels like. But yeah, the radio station analogy I like. Okay, so with this diagram, I wonder if I can, is it okay if I erase this diagram? Okay, because I can't draw over it. So just remember that in your head. Erase the diagram. Okay, so now let's run this. Okay, so what am I doing with this request? I'm just saying I'm going to visit the site. I'm just going to make a GET request for lecture1.html. So if you do the readings, you'll see that HTTP, you can have certain kinds of requests, and GET is the most common one. GET just means get me something. And the something I want to get is a thing after my domain. So this is really a request for get lecture1.html. So I talk to the web server and say, get me this thing. And when I press enter, it fulfills my command, gets me the thing, and then I print it out. So this text is being printed on my computer, but it came from the internet somewhere. So if I don't want to actually do this because it might not connect on. If I disconnect my internet right now and I run this, it won't work, right? Because I can't connect to the server if I'm not on the internet. So this is coming from the internet. And notice how there's a little delay because it takes a while to get there and back. So what is this? So if I scroll to the top, here is the response from the server. So this is the response. Whoa. So it says, sorry, let me scroll back up. The response says, so this is a response, right? It starts here, right? I press enter, and everything below is the thing that the server sends back to me. So there's a bunch of details here, but basically what this is, it's called the header of the HTTP request. So this is the HTTP header. It's all plain text, first of all, right? So everything is sent over the internet in some plain text format, and I print it out as plain text. So the HTTP response from the server has some format that you can read about. You don't need to know the exact thing, but you have to know there's some format. There's the kind of HTTP, so this is called 1.1. It's just the protocol number. 200 OK is that's the response code for, like, things went okay. I responded to you, everything is fine. So if you go to some sites, then you might get like what's called a 404 or 403. You might, like, if you go to the wrong page or it doesn't exist, you might get a 404, some kind of other code error. That's what it means. It just means it's just some code for I can't find what you want or anything, or it's been redirected. Here's some other information in the header in the kind of name tag pairs. So this says the server software, NGINX, that's just the software that I'm running. This is just information. This is for caching that you'll see later. Content length this is how many bytes the response is. So it may be important to know this because I want to, if I have a piece of software, I want to read 683 bytes. I know how much I'm getting. This is pretty important. This is the content type. This says that what you're about to get back in the rest of this response is text/HTML. It's a kind of HTML document that you should know what to deal with it. Last modified, this is used for caching. So these are optional headers so that if you want to, if you're a web browser wants to implement some kind of cache to speed things up, you can use that information. And then this is, I guess this is our current address of our Rochester our internet. So after the header is followed by a blank line. This is actually really important as you'll construct your own request later. You need a blank line, between the header and what's called the body. So you need actually, an enter a blank line, and the rest is the body of the HTTP response. Right? So the header has a bunch of information. Everything response has a header, and then there's a body, and your readings show you what the header is. Okay, so what is the body? The body here is simply, I'm just going to scroll, is simply the HTML web page I'm requesting. So does this look? This should look familiar from last time, because it's exactly what we wrote. So HTML, there's no coloring here because I'm not in the text editor, but HTML, head, title, blah, 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 blah. All right. That's just the text. So once again, if I make a request, I get some header back, and then I get some body back. And that's all. Okay? So what if I do this? What if I do that? What do I print out? Whoa. Yes, question. Picture. Picture? It's one idea. Other ideas? Huh? Numbers. Okay. Which ones? 1 and 0. Good. Those are good numbers. Yeah. Other ideas? Yeah.
Print out the hex of the image.
Yeah, it'll print out some kind of hexadecimal representation, so some kind of number representation. So those are all great guesses. So if the terminal actually was smart enough to display a picture, it would display a picture, but unfortunately it's not, so it displays that. So it basically throws out garbage to terminal, and this is really just the encoded data in some way. It's just that the terminal can't read all these ones and zeros. I mean, it's essentially ones and zeros or hexadecimal. It's just a bunch of binary data, because your JPEG image is just a bunch of ones and zeros. It's not plain text you can read, right? Your image is a bunch of ones and zeros that represent the pixel colors and encoding and everything. So this is all junk to the terminal, which is not amazing, but there's still a header. Oh, I hope I see the header. It's really big. Well, if you're like really awesome, you can see the image right here, right? If you just scroll through fast enough. All right, it's too big. So let's actually just put it to a file. So if you're familiar with command line tools, if you use the right angle bracket or greater than, you can actually redirect the output of the terminal into a file itself. So I'm going to call this response.txt. So what this does is that it actually sends all that gibberish that I responded to a text file that I can look at. Okay, so notice, ignore all the weird characters and stuff, but notice how there's still a header, right? The header still looks like plain text. Response, okay, the content length. So this is about 64K big. So this is about this is how many bytes it's big. So that's the image size, right? So the image size is around 64 kilobytes. Now the content type is different. It's now an image/JPEG, right? Remember when we request the HTML file, the content type was text/HTML. This one says this file is a JPEG image file. So everything else below this, get ready. When you hit the body, you better be able to grab those ones and zeros and like display them as a picture. Because you can't, then your luck is out. So notice how there's an empty line. The pound M's are because the terminal doesn't display it right. But there's an empty line here, and everything down here is the JPEG data. So it's just a bunch of ones and zeros, but it's displayed in the terminal in some weird way. So clearly you can't read this, but you actually notice that it actually has some text in it. Right? There's some RGB, some other sorts of textual information, but for the most part, it's a binary thing. Okay, so what we've done with this curl program is basically we were like a web browser, right? All we did is instead of using a web browser, we use curl to manually go and fetch these things from the server via HTTP. We fetched both the Lecture 1 HTML and the truck.jpg picture. We fetched those two. All the data is there. But the problem, of course, is that if you're just on your terminal fetching this stuff, this is not super useful, right? You're just viewing this as either garbage, because the picture is garbage, or you're viewing the HTML with its raw code, right? You're just looking at the raw data. But you get all the data is on your computer now, right? You can actually use curl to grab all the data on your computer, and it's there. So now actually comes what the web browser software is, right? So when you're running Chrome or Safari or Internet Explorer, all your web browser is doing is essentially doing what curl is doing, except the web browser, instead of being this really simplistic text-based terminal, it actually knows, like someone suggested, if my terminal was smarter, it could display a picture, right? There's no reason. This is all the data for the picture. There's no reason why the terminal can't just plop a picture right there. It's just that terminals are meant to display text, not pictures. So all web browser is it just makes these requests, and it takes this data, and it manages to render it as nice looking pictures like this, or like this. So this is a truck.jpg. So this is exactly the same. The lesson here is this is exactly the same as doing this. Doing this is the exact same thing as hitting reload and doing that. Exact same thing happens. As far as the server is concerned, somebody from this laptop is requesting a bunch of bytes, and it's giving back to me. But clearly, you don't want this and you want this, right? Because you can actually see it. Okay, so let's go to so now you can actually follow along, because we'll go to lecture1.html. So in your web browser, if you want to follow along using Chrome, you can follow along right now. We're going to use the inspect element. So we're going to right click anywhere on the page. Inspect element for it to pop up. I made the font bigger here so you can see. Control, whoops, that makes this bigger. Made the font bigger. If you go to this thing called network, this will actually show you all the requests it's making. So recall that we use curl, which is just some piece of software. So let's get lecture 1 back for us, because it's shorter. And this returns you the HTML, but beforehand it returns you this this header here, right, with all this information. So we're going to show you how you can use the web browser to get that exact same thing. So there's no magic behind it. So I'm in my web browser. I'm just going to reload the page. I'm going to have this Chrome thing open. So do you remember inspect element, and then hit network. So now what you can do is you can press. I actually put disable cache as well, because that complicates things a little bit. So disable the cache on your browser. Now when you hit reload the page, it will actually show you what's happening on the network. So I'm going to hit reload. And 3 things happen. All script. All right, so let me grab this. I think I'm zoomed out too much. Let me update this one more time. Here we go. It's just my thing is too zoomed in, so I can't see. The resolution is way too low. Let's try this again. Okay, let me move this bigger. I'm just messing with the screen here. See everything. Can I close this? No. All right. So this is tough luck. It's just a little too small. I'm gonna reload. All right. Can people read the font down here? Okay, it's a little small, but I want to maybe make it a little bigger. Maybe we'll see it in the back. It's just that this bar is in the way, which I want to hide. No, that didn't work. Just want to hide this bar, so. This is aggravating. The bar can't be hidden. All right, anyways, I'll zoom out a little bit. Okay, so my screen isn't quite big enough to see everything, but just the important thing here is that the web page is up on top here. So you can't see much of the web page, but it just trust me, it's still there. I just want to make this screen on the bottom really big so you can all see it. The important thing here when I reload the page is, I'll clear this so you can see it's empty. So the important thing is when I reload the page, something happens down here. So pay attention down here. When I reload, several things happen. So the first thing that happens, there's a timeline here, which is cool too. the first thing that happens is 1.89 seconds. Okay, so the first thing that happens is I fetch lecture1.html from the server, and it's because I asked for it, right? I asked for lecture1.html. The first thing that happens, this is get, which is the kind of HTTP request I get. This is the response status. This is the type of stuff. This is the amount of bytes in it, 994, and this is the time it took. It took about almost 2 seconds. So this is kind of the timeline draws out. It took about 2 seconds for my computer to go to that server and come back. So this should be around the same with curl. So if I do this, oh, this is actually cached probably, so it's actually faster. But if this was not cached on my computer already, I need to disable cache on curl, it would take, say, like 2 seconds. This grabs the HTML file and then also grabs some other stuff. So let's just look in the HTML file first. I'm going to click on it. This just inspects all this data. So I can make this bigger. So these are the headers. So notice how the URL I requested is this. The kind of request is a GET request. Now here is the response. So this is all nice and parsed out. Like it's all in a nice format, but you can actually look at the raw response here, which is view source. So if you squint hard enough, you notice this. This is the exact same header as we got in curl, or at least it should be. Blah, 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 connection closed. So this is the response. So remember, this is the header. So if I'm in curl here and I do this, the header should look like this. So that's the part that's the header, which the browser got, because it's getting the exact same information from the server. And then, let's see, anything else in here? Request, response. And then there's the actual response itself. So the response itself, because the header tells you it's a text/HTML, the web browser knows now that the rest of the information it's going to send me is some kind of a piece of data that we should render as an HTML file. So we know how to render HTML files because that's exactly what the web browser does. So the web browser takes this HTML response and does its magic and renders it as a web page like this. Right? Renders it as a web page. It doesn't render it as, my terminal just knows how to print the text out, which is not very informative. But the server knows how to, the web browser, Chrome, knows how to make the fonts big and make the colors and stuff. So another part of this is where the truck picture comes in. So when does the truck picture start loading? In this, if you look at this diagram, this timeline. After the file. And how come? Why couldn't we load at the same time as the file? Yeah.
I'm not sure why not at the same time.
Sure. But you're saying after the file, right?
Yeah.
Okay. So why can't we? Why is this time? So this is what you all noticed here is we load this first, and then we're done, and then we load this, right? So
like you wouldn't know that it needed that image until it was parsing the HTML file and saw like this image at this location, and then at that point you'd go and grab that.
that's right. So the answer was you can't start loading the image first because when you request lecture1.html, it doesn't know that you want a truck picture, right? It has no idea you want a truck picture. All it knows is I want lecture1.html, so I'm gonna go get it for you. And like you mentioned, as the web browser starts parsing this, as the web browser starts processing this HTML file to display on the screen, it actually just processes it top down. It actually is really simple. It just goes head, title, display the title, get some CSS, load these rules, heading, and oh, right here. So I'm here. I need to have this image tag here, and it says truck.jpg. So then the web browser here knows, okay, I need to get a truck.jpg picture because there's no truck here, right? Like no matter how hard you look, there's no truck inside of here. Right, so it needs to actually grab another thing called truck.jpg. And where does it grab it? Because the link is just a file name, it just grabs it from the same domain as before. So as soon as the web browser hits this, it will trigger another GET request. So the web browser automatically does a second GET. The first one is initiated by you, right? You have to say it. The web browser, as soon as it sees this truck.jpg, it will make another request. And if you actually notice, can I close this? If you notice this initiator, this is who initiated this GET request. This says other. This just means you know, or your web browser. This initiator is actually lecture1.html line 46, which is right here. Perfect. You see how if you look at the, if you click on it, the Chrome, it actually shows you a line. It shows exactly what line was triggering the second GET request. So if you go here, ooh, network. So I'll call I click this, lecture1.html, it shows and actually highlights nicely the line. So the Chrome browser actually does this for us. So recall if I had to do the old school curl way, I request the HTML, then I have to look at it myself and say, oh, I need a truck picture. So I need to go like this and request it myself. I have to do 2 requests, right? But with the web browser, it actually, you make 1 request for a lecture and it knows, because it knows the picture is in the lecture, to do the second request. And if you look at the second request, the headers, the URL is pgbovine.net/truck.jpg. Right? It's the picture. And then what's the body? Sorry, the header. The header is the exact same header you saw in the curl, except this time look at the content length is 64,000 and the content type is image/JPEG. So recall if we look at curl again, do it to the file because it's too long. If you look at the head, it's 64937 and the type is image JPEG. And now remember, once we have image JPEG, then everything in the body after the header, the web browser knows, okay, a picture is coming, so we better prepare for it. So like someone up here mentioned, it would be nice if the terminal displayed a beautiful truck picture here, but it doesn't. But fortunately, the browser knows how to display. So this is the response. So it's a picture, because the browser knows how to render pictures. So that's the actual data, truck.jpg. There's some information about it. So those are 2 main bits of data. This is some extra icon that a lot of web pages has. If you actually notice, this is trivia you don't need to know, but this favicon.ico, if you have a file called this in your home directory and your server, it will actually load that file and use it as the icon up here. So if you actually go to Twitter, that's the Google icon, it's the Twitter icon. That's why there's a third thing being loaded. So I just want to show you there's no magic here. But the third thing being loaded is this icon, which you don't need to care about. Yeah?
Guys, can you explain why the truck image is loaded after the HTML? Meaning there is no overlap in the timeline.
Yeah, that's a good. So what would you expect?
I mean, in between, right? When you read the truck image in location, then go to that.
Yeah, so you would expect, so I think one of the intuitions here, so the question is, why is this actually not overlap? Because you would kind of expect this, right? That as you're processing halfway through the HTML file, you start loading the truck image. I think the answer is they count it. They count this by receiving the whole file. So you have to actually receive the entire file first. And once the whole file is received, you start processing it. So this actually ends when the file gets to your computer. And then after the whole file gets to your computer, you start processing it. You can imagine a case where it starts processing it before it gets to the end. I think it may be because I disable caching as well, but the overlap or not overlap is not super important. The idea is that it doesn't start like here, right? It's just a little bit of edge case. Other questions so far? Yes? What's the green and blue? Yes, so let's actually hover over it. These are all performance things that you don't have to worry about too much, but if you hover over it, the green is waiting TTFB something, and the blue is the actual download time. So there's some waiting phase. You can actually look this up. I don't actually know what this acronym stands for, but there's actually some, if you notice how it's actually not just green and blue, there's a lot of different phases here. And this is, again, to somebody's point up there, of what happens when you type in the URL. There's actually a lot of stuff that happens behind the scenes. There's a thing called a DNS lookup, the connection, request sent. Oh, this is, I'm assuming this waiting is you send the request and the server is doing something. And then we start downloading. That's how much time to download. So these bits of information are really important if you want to actually optimize and make your site faster. But for this class, we won't think about that part, the performance part. But this is actually really important if you're loading a site and it's loading slowly. You really want to use this dashboard to see which parts are taking too long and which parts you could optimize. Yes.
So for the time that it takes a site to load, you mentioned that a lot of people select Texas because it's right in the middle of the country.
Sorry, Texas. Yeah.
Texas, right? When you select the server, you
Uh-huh.
have the choice to choose the city. And then I was wondering, I have tried the trace command.
Yeah, the trace route.
Sometimes it's counterintuitive. The route, the path.
I don't have it on here. Yeah, so the real image is a little more complicated because, so this is again out of the scope of the class, but I'll explain in 2 seconds. Is basically the image that I've displayed so far is, let me draw on this other one. The image I've displayed so far is that you have one server somewhere, and I just say Texas. I don't actually know where it is. I'm not advertising Texas in particular, but let's say it's a server, it's somewhere in Texas. And it's getting to me. But if you visit, say, google.com or Facebook, let's say it's facebook.com, chances are your facebook.com is probably not one computer in Texas somewhere. It's probably replicated on hundreds or thousands of computers all over the world. And when you say facebook.com, there's some magic that happens that reroutes your facebook.com requests to probably the closest one to you right now. So if you visit it up here, you might get to one in New York. Visit in California, you might get to one, in California, Oregon.
When you choose a server, they don't have they can't afford what Google can afford.
Right.
So they give you a choice.
Yeah.
So like if you want Texas, or they give you like 5 options.
Right.
let's say. And then it would be a good idea to choose depending on your audience. So that
Yeah, I think it's usually good. I don't think it matters a ton, but yeah, I mean, if you really care about performance, you should select, if most people are from the US, you should select, central in the US. If people are international, you might want to select different ones. In reality, unless your site, you wanted to go really fast, it doesn't matter. I mean, people can access from Europe and it should be fine. Maybe a little bit slower. Cool. Other questions? Back to this diagram here. So that's the main diagram that we have for this class. Let me look at my notes, see if we have any other things. So I'm going to go to the recap right now. And now notice how we did the web server. We did HTTP, which is the language, this GET request kind of language with all the blobs of text that we use to talk to it. And then what happens when you hit a URL and type enter? It just returns the stuff. So the last thing we're going to cover is this thing called caching, which you might have seen in the we'll see if this actually works. It depends on how my server is set up. It might not actually, the demo might actually work. So the idea behind caching in a general sense is that if your thing isn't changing, there's no point in going and fetching it from the server every time. So if I disable the cache on my browser now, so if I hit reload, sorry, I'm gonna make this bigger again. Every time I reload, notice the timeline. It takes a few seconds. Sometimes it's longer, sometimes it's shorter. Oh, that's fast this time. It's not that fast. It's kind of random, right? It's faster. So every time I'm doing this, I'm actually taking a second or two, grabbing the HTML, grabbing the truck picture. But really, like, that truck picture in the HTML file never changed, right? I didn't alter it at all. So what your browser can do, what your web browser can do, is it actually has a cache, which is just some data that's storing. What you really want your browser to do is just to load it once and store that copy of the HTML file and the truck JPEG in your computer on its hard drive. So when you hit reload, it just loads the picture from your hard drive in the web page from your computer. It doesn't actually have to go to the server. So ideally, you'd want that to happen, right? So what happens? So why can't we just cache everything? Well, it's too much. That's good. So it's too much stuff. You can't cache the whole internet. Good. If we could cache the whole internet, why should we?
I don't want to look at like 2008 Facebook.
That's right. So you don't want to look at data that's old, right? So this I can cache because it never changes, but your data will, anyway, you go to a news web page, for example, right? Your data is going to change every day. It's going to be a new page. So one issue with caching is that you need to know when to kind of disable the cache, right? And that's a bit more complicated topic we won't exactly talk about now, but there's usually in the header in these HTTP, there's usually expiration times and last modified times. So if you notice how this header has it has the last modified time right here. So it says that this file was last modified on this day. So you could use that information sometimes to help you compare and to determine when to cache. Even if your cache works really well on your browser, how many of you had, you might have recognized an experience where you go to a website, it loads like instantly, but it's kind of old and it doesn't look that good, and you just hit reload and it actually takes longer and loads the real site. This happens on some sites if they set the caching policies not super good, because they want the site to load fast, even if it's not completely accurate, because then it just loads whatever's on your computer. But then if you reload, usually if you reload like twice, it'll like do a hard reload, or you can disable the cache as well. So if we enable the cache, if we don't hit disable, let's see what happens. So I uncheck disable. I'm going to reload. it's going to do all this good stuff. I'm going to load again. Now notice the timeline. I'm going to load again. See what happens. Oh, I think the cache is actually disabled on my server. Oh no, it says from this one is from the cache, but these two are 304. No, actually this is good. These are actually fine. Well, it's hard to tell if it actually is any faster, but the difference here is that these say 304 now instead of 200. 304 means this data was not modified, so you don't have to re-download it. So we just basically the server checks that the time has your file hasn't been modified since you last requested it, and it just says not modified. You don't have to download the whole thing. It doesn't really matter here because it's actually pretty fast. But if you have big sites, just remember the caching is an issue. So for the purposes of your project, just remember the caching could be an issue, and if people are having trouble loading your site, just have them reload a few times because then that'll just kind of get rid of that. Also, if you open it in incognito mode and you close incognito all the windows and reopen it again, that cache will be empty. So testing your site in incognito mode is actually somewhat useful because it makes sure that the caching effects are minimized. Okay, so let me see what other stuff in the notes toward the end. So there's cache, HTTP GET, domain names, everything. Okay, so just to recap today's class, one a little bit early, people have questions afterwards. We talked about what a web server is, which is just a computer somewhere on the internet. And there's a piece of software on your web server, also confusingly called a web server, like Apache, Nginx, or Microsoft Server. HTTP is the language you use to speak to web servers. So HTTP is just a language that's based on text that you send information to and from. And then when you type in the URL and you hit enter, what happens is it makes an HTTP request from your laptop, right, from the laptop to the server through HTTP. This is the language you're speaking. Server does something, gives you an HTTP response back, and your web browser renders nice looking pictures and text and everything. And you don't need a web browser necessarily to do HTTP. You can use a command line tool like curl, but there's no reason for you to actually do this. I'm just showing this as a demo just to show that the web browser does the exact same thing as this command line program would, except it actually makes it all look nice. Any last minute questions before the to-dos for next time? So I'll be here for a few minutes afterwards. So the to-dos for next time. So if you haven't yet registered, so I have now, I think around 78 on Blackboard registered. So the cap is 80. So it's getting pretty close. So if you haven't registered, come talk to me. And look for a Piazza email this weekend. So we're going to use Piazza as the discussion forum for answering questions about lectures, projects, and finding groups, because it's just a lot easier than emailing myself and 6 TAs. And start thinking about project partners. So in order to stay in this class, you need to have group. We don't want to have solo projects because there's just too many of you. So groups of 2 or 3. Everyone last year was able to find a group, so don't worry about that if you don't have a group yet. There will be other people without groups, and we'll message on Piazza. If you want to download and install some of the software on your computer, play with it from the course website, you're welcome to do so, but that's completely optional. So we'll see you all next Tuesday after Labor Day then.